Okay, thank you for confirming. Soon we will start. Okay, so a very good evening, all of you. Today we are going to discuss about the previous year questions, and it's a long-lasting session in which we will cover the questions, previous year question onwards from 2018. So today we will discuss about the 2019 chemistry question portion. Uh, Again, I would like to confirm, am I audible to all of you? Anyone, please? Am I audible? Okay, so thank you for confirming. So I'm Naveen Kumar and I have completed my MS5 from Naipar, Ahmedabad. Today I'm going to take this session of previous year question, that is GPAT 2019, and I'm going to discuss about the chemistry question. Almost all the questions of each and every subject is going to be discussed in the different sessions. Different faculty will take the classes, and today I'm going to begin this session with the 2019 chemistry question. So we'll start with the first question, and in the very first question, we are going to see the what is the question, and after that, in each and every question, we are going to see the correct options, and we are going to keep it as two base options also. Why the answer is correct and why the other options are incorrect in the concept behind it. Somewhere we will also discuss about their theory, related theory, so that our concept is going to be very clear. So the first question is, choose the correct product of the following reaction. And what the reaction is talking about a reaction of nitric acid with the 2 mole of sulfuric acid. So here you can see that one nitric acid is being reacted with the 2 H2SO. So what will be the product? So these kinds of questions are actually very, very easy. But what stops us, that is the concept behind it. If we know about the concept of these kinds of questions, we will be able to solve these questions within the fractions of seconds. Yes, you heard right, within the fractions of seconds. It's almost hardly 1 second question. Like you should be prepared in such way that you see the question and you just click on the answer. So when these kinds of question appears, you firstly need to memorize from where this question have came. So see, so basically HNO3 and H2SO4, that is the sulfuric acid, both uses in the nitration process. So in nitration, we use the HNO3 and 2H2SO. So remember, what is the nitration? Firstly, remember, and then we are going to discuss the correct options also. Any one of you having any idea about each in this classes, any student is there? Is any student is attending the classes session? I'm not aware that whether a student is here in this session or not. So if yes, just let me know. Or only technical team is in this session. Uh, any students? Okay, okay, okay. Got it. Okay. So see, so basically this both uses in the we uses this both in nitration reaction. So basically nitration is a kind of electrophilic reaction. And in electrophilic reaction, what is going to be react? That is the electrophile. And what is the meaning of that electrophile is, electrophile means a compound or a molecule or a functional group which is having positive charge. So one thing is clear, that when this HNO3 and this 2H2SO4 is going to react, there will be NO2 plus. So see, out of the four answers, only options A and B is containing nitro positive charge, Na2 positive. The remaining C and D is not possessing any positive charge. Means the options C and D are incorrect. And the correct answer will be either option A or option B. So sometimes if we eliminate the incorrect option, then the remaining one will be our correct answer. So see what will happen when HNO3 and 2H2SO4 will react. So the correct answer is, when the HNO3 and H2SO4 reacted, it gives H3O plus 2HSO4 minus plus NO2 plus. Now we are going to see the concept behind it, how it's being reacted, and where we are going to use. So as I have discussed, the HNO3 along with the sulfuric acid being used in the nitration process. So this is what I am going to discuss with you all. Basically, it's a reaction between the nitric acid and sulfuric acid, and which is important in nitration process. When we talk about the complete reaction, when the 1 mole of nitric acid reacts with the 2 mole of H2SO4, it gives H3O plus 2 mole of HSO4 minus plus NO2 plus. The important thing is here, that is NO2 plus means it's a nitronium ion. And this nitronium ion is going to replace any one of the substituents in the electrophilic substitution situation. So this is what I was talking in the beginning of the classes. You must have the knowledge about the basics. So if you are aware that the HNO3 and H2SO4, if they both are in option, means there is possibility that the nitration reaction is going on. And in nitration, what is necessary? Nitronium ion. Nitronium ion means NO2 plus. So see, so here option C and option D is incorrect option, while either the option A and option B was right. So when you balance the reaction, you will be able to find out. In this case, see, you have to count what till now what we have eliminated, option C and option D. Now we are going to see the balance of reaction. Balance of reaction. Here you can see the total number of hydrogen is 5, 1H, and here 4H. The total number of hydrogen is 5. While in the case of option B, the total number of hydrogen is only 4, means H2 and 2. Means total 4 hydrogen is here. Means this reaction is not a well balanced reaction. It means option B is also a incorrect option. And option A is the only correct option. Sometimes you don't need to see only correct option. Just eliminate the incorrect one, and the remaining one will be your correct answer. Here, a detailed explanation about this reaction. Basically, in the nitration, sulfuric acid acts as a strong acid as well as a dehydrating agent, which will lead to the formation of nitronium ion. And this nitronium ion is a electrophile in nitration reaction. This nitronium ion is going to be reacted, and it will give you, when we treated these molecules with the benzene, so it will give nitrobenzene or nitrotoluene or anyone. So the overall product will be nitronium ion, which will give the electrophile, and which is going to be used in nitration process. So what is the correct answer of the question number 1? That is the option A. And the reason behind it is that it is a reaction of nitration process. Now, sometimes what happens in the GPAT, the examiner asks the direct question. And dear, always remember that the direct question is always a part of your direct knowledge. Means in the direct question, most of the time the question is so direct that with the help of your knowledge, you will be able to identify the correct option. Like this question here, they have directly asked about the name of a given structure. So examiner have given us a few structure, and this time one structure, and they are asking that this structure belongs to which drug. So dear, in this case, what you need to remember, the structure. In this kinds of question, there is no shortcut. You must have to remember the drug structure either with the help of the mnemonics, the tricks, or with the help of the side chain. Sometimes you can remember the structure with their side chain one. So dear, here you can see a given structure is here, and the name, the given options are esmolol, pitaxolol, metoprolol, and bisoprolol. So in this kinds of question, what you need to remember the molecular structure of the drug. These all four drugs belong to the category of beta blocker. So for this, now we are going to see all the structure of these four. And with the help of that, you will be easily able to find out this structure belong to which drug. Again, I'm repeating, sometimes you need to remember the structure. There is no shortcut. Either remember the structure with the name, with the help of mnemonics, or remember their side chain, which is going to help you in your examination. So the correct answer of this question is bisoprolol. Means the given structure belong to the bisoprolol. So now we are going to see the structure of these all four, and then we'll try to memorize the bisoprolol structure with the help of some how and some mnemonics. So here you can see the structure of esmolol, betaxolol, metoprolol, and bisoprolol. These are the four structure of all given four options. In this structure, what is the eye-catching thing? That is the isopropyl. Here you can see this one is isopropyl. One, two, three. I'm going to use somehow pen. This one is C, C, and C, right? So this one is isopropyl, and this one is also isopropyl, C, C, and C. So here you can see two isopropyl chain is in this structure. So now we are going to see the structure of all the four, and we'll try to find out the correct answer. So here is the structure of all four. So you can see in the case of esmolol there is only one isopropyl. In case of betoxolol, the same one isopropyl. In case of metoprolol, only one isopropyl. While in the case of bisoprolol, there is two isopropyls. So the given structure belongs to bisoprolol. And what will be the mnemonics to remember this? Simply remember bi. Bi means two. Bi means two. Two isopropyl chain will be there in the structure of isoprolol. So always remember, if there is two isopropyl chain, you are saying that a structure of any beta blocker, there is a possibility that this particular structure belongs to bisoprolol. Here, this is just a way to remember the thing. This is not a very good or very correct way. The correct way is that you should remember the all of the structure which we have discussed already in the medicinal chemistry classes. So this is just a wrapping of the class. Now we are going to see the just a minute. I'm going to remove these animations. So Now, a very interesting question is here. You all might be able to see this one is a very interesting question, and this kind of question used to appear in the GPAT examination and sometimes NIPER examinations or other central university examinations. The question which we are discussing here in this session, or the question which are asked in the GPAT, this is not only necessary for our GPAT preparation, but also it's necessary for our NIPER preparation, for central university examination preparation, for different kind of pharmacies, drug inspector examinations, drug analyst examination, and a lots of pharmacy examinations. So the question is, what will be the heat of vaporization of 1 mole of water when it has the entropy change of 35.2 kilomole per degree at 25 degrees Celsius? So see, to solve these kinds of questions, you need to remember the formula. If you know the formula, there are very less formula, very few formula in our chemistry. So you should memorize those. If you having the idea about those formula, so just what is the left, that is your multiplications, divisions, subtractions, and addition. If you have idea about the formula, then these all questions uh, are uh, of less than 1 minute. Means you will be able to solve this question in less than 1. So the given question is talking about the calculation of heat of vaporization. And the given data is entropy change, the given data is entropy change and temperature. So now we are going to see the formula before the calculating the answer. So see, the formula is very normal. To determine the rate of vaporization, we are going to use a thermodynamic relationship, or you can say a very easy formula. That is, the heat of vaporization is equal to temperature multiplied by entropy. So here you can see it's a very it's a very short formula. It's a very short relationship, that delta F web equal to T dot multiply by delta S, where delta H web means the heat of vaporization in Kelvin, while the T is the temperature in Kelvin and the delta S is the change in input. So the given temperature was in degree, that is 25 degrees Celsius. So foremost, we are going to change this Kelvin, this degree, 25 degree into the Kelvin. And to change the degree into the Kelvin, we have to add 273. It's a very simple formula. Just add the 273.15 in the degree Celsius, and you will have your answer in Kelvin. So the temperature in Kelvin will be 25 plus 273, that will be the 290. And entropy change was given, that is the 35 point. Just put this given data in this relationship and you will have your answer. So delta H wave equal to 298 multiplied by 35.2. And when you do the multiplication, you will have an answer 10489.6. So the correct answer will be 10489 calorie per food. So this is the correct answer. So option B is the correct option. Again, I'm saying few questions are like they will look big, but they are very simple. So for those, what you need to remember, you need to remember the different relationship, different formula, different kinds of structure, and different kinds of thermodynamics relations, chemicals relations. So if you know about the formula, if you know about the relationship, so these kinds of questions will be of will going to take your less than 1 minute in the exam. Now moving to the next. The next question is related to the infrared spectroscopy, and it's a very you can say it's the most frequent questions in the GPAT or NIPER. In the GPAT and NIPER examination, this question used to appear frequent. The question is related to the new job, and it's talking about their IRF job. So for this kinds of question, what you need to remember that what is the IRF job term, what are the different kinds of vibration in IRF job. So the question is asking about the infrared absorption peak of nodule is due to what? Means if we are we are seeing the peak of nodules in IRF spectra. So this peak is due to what? Means which vibration is involving here to give the particular absorption peak in the nodule compound. So for this, you have to remember the two important things. First, the basics of IR spectroscopy and the structures of the nodule. So see, the correct option will be the C only, but we are going to see the what will be the correct options and how we are going to see. Basically, dear, nodule is a mineral ion and it's primarily composed of only saturated hydrocarbon. So if anything is composed of hydrocarbon, then you should remember that the sulfur is not going to be the right option. Means this sulfur, the option A, option B, and option D, that is the nitrogen. Means these three options are the incorrect options. So in the beginning of the session, I have already talked about this. If you eliminate the wrong answers, wrong options, then the remaining one will be your right option, your correct option. So, nuzole is basically primary saturated hydrocarbon. It's a natural mineral ion. So, if it's composed of hydrocarbon, then there is no way that the absorption, the vibration frequency is due to sulfur, nitrogen, or oxygen. So, of course, the option C is remaining, and that will be our correct. Also, you need to remember what is the meaning of this STR and what is this meaning of D. Basically, this STR is the shortcut of stretching and this DF is deformation. So we are going to see the stretching and deformation, what is this term and how this arises. So see, so in the IR spectroscopy, there are different kind of vibration. So two major kinds of vibrations happens in the molecule. I'm going to show those with the help of a pen. So what happens in the molecule? See, a molecule like remember, imagine it's a CH, right? So CH. So there is a bond between the carbon and hydrogen. So when we talk about the bond, so this bond in the vibration case, this bond can either stretch. What is the meaning of stretch? Stretch is nothing but a phenomena of a spring. Like in the case of a spring, what happens? They go upside and downside. So that is the basically stretching, or in case of natural rubbers, right? So what happens in those cases? There is a natural stretching. So if the bond length is increasing or decreasing, bond length, I am again saying if the bond length is increasing and decreasing. So this phenomena is known as stretching. We can observe the stretching phenomena in our home also. And we used to do this kinds of activity with a lots of elastic polythene and a lot of things. Like so the most common is the spring. It's very similar to the spring. So if the bond length is increasing, decreasing, that is known as stretching. That is stretching. So what is the meaning of? Okay, for sure. I'm going to repeat. I will repeat again. Not an issue. So see, I was talking about the vibration. See, just imagine there is a bond between the two. There is a bond between two atoms. Imagine this: the two atom is carbon and hydrogen. So when this vibrates, imagine two things are coated together and when the vibrate, the two phenomena can happen. The first is the their length can shrink or elongate. Means they can either be big or the bond will shrink or it will enlarge. It will be like the stretching phenomena. The stretching of the it will be very similar of the stretching of any string. And the second one is that the change in bond angle. Here you can see this one is directed. So, so what can happen? The bond angle changes, right? Like it will become like this, or it will become like this. So this is known as deformation. And deformation is also known as bending. So remember, there are two major kind of vibration in IR spectroscopy. The first one is stretching, and second one is bending. And bending is also known as deformation, and it's generally denoted by the DF. So in this kinds of question, what you need to remember that the what is the structure of any molecule. So, as we have already discussed, the nodule is completely composed of carbon and hydrogen. It's a hydrocarbon. So, if anything is composed of completely carbon and hydrogen, then there is no point that the vibration is due to the either sulfur or nitrogen or oxygen. Means these three option A, B, and D are the incorrect option, and option C will be the correct one. Now, we are going to see the few more questions which are directly from some guidelines. So, dear, these kinds of question also appears in your examination. In this kind of question, the question is directly from somewhere like some guideline. The question, okay, so I'm going to, okay, see. So the question was, the question is from, okay, so it's Harika. So see, basically, H is hydrogen and STR means stretching and DF means deformation. I think it's clear now. STR means stretching and it's deformation. Okay, good, good. So see, sometimes examiner asks direct questions from your a few guidelines. So see here, there is British standard 1792. So we all aware that we were under the control of British before the 1947. So most of the things are still belongs to them. Like a lot of guidelines are very similar to either the British or they are HM till date, right? So this is a question related to a British specification 1792, and it's talking about the permitted tolerance limit. Serious. In the each and every guideline, there is a permitted tolerance limit. So this is talking about the volumetric flux limit of 100 ml and 1000 ml. So in this kinds of question, nothing is going to help you. There is no calculation, there is no need of anything. So you just need to remember the guideline. And I'm going to show you firstly guideline and then we will discuss about the correct option. So see, so as per the British standards for laboratory glassware, the tolerance limit for the 100 ml volumetric flask is plus minus 0.30 ml. And for the 1000 ml, it's plus minus 60 ml. It's as per British standard. There is no shortcut. You need to remember this data. That will only help you. Nothing is going to help you in these kinds of questions. So see, so from this, you can see For the 100 ml, it's 0.30, and from the 1000 ml, it's 0.60. So here you can see the option A is not 0.30, option C is also not, and option D is also not. So option B is the closest one, and your options will be option B, that is 0.30 and 0.80. Basically, the 0.80 is of 1000 ml, and sometimes this happens like the exact option will be not there. You have to choose the correct option very wisely. Means the answer should be like 0.60 directly, but there is no direct option of 0.60. So the closest one is 0.80, and your correct answer will be 0.30 and 0.80. So few times the questions from the direct guidelines also appears in each subject. It's not only about the chemistry. These kinds of question appears in the These kinds of question can appear. Okay, so see here is the explanation here. Uh, is it visual to you, Radhika? Okay, see you people can take the screenshot also. Okay, good. So sometimes these kinds of question appears directly from the guideline. Now we are moving to the next questions, and that is going to be very interesting question. This kinds of question, this kinds of question is you can see this is a kind of horror question for the pharma student. When I was a student, I also used to fear from these kinds of questions. But believe me, when you learn the concept, you will be able to solve this question in seconds. Okay, so the question is talking about the addition of two substances. And after that, what will be the pH of the resulted solution? So the question is very easy. It's talking about it's talking about when we are going to add 50 ml of NaOH 0.1 molar to the 100 ml of 0.5 molar acetic acid, then what will be the pH of resulted solution? And their dissociation constant is given. Dissociation constant of acetic acid is given, that is 1.82 into 10 to the power minus 5. Therefore, the explanation of this question, I am going to use one image. So see that image carefully and listen the each and every word, each and every step carefully to know the correct option. So it's for now the correct option is 4.74, but we are going to see how this 4.74 will come. So see here, these kinds of question you need to solve in four steps. First, identify the reaction. You can see the reaction is happening between a acetic acid and a base, means OH minus NOH or OH. So after the reaction, what will happen? We will have acetate ion. Okay. So the salt will be of acetate. In case of the sodium hydroxide, the salt will be of sodium acetate. So if we talk about the sodium hydroxide, the salt will be of sodium acetate. And the next step, calculate the mole. There is a very simple, easiest formula to calculate the mole. Mole is equal to the volume into concentration. You might be aware about a very close formula, that is the N equal to CB. I'm going to use my pen to show you N equal to CB, right? So here N is the mole, C is the concentration, and V is the volume. So step one was to identify the reaction. In the second step, we will calculate the moles. So with the help of the given data, we can calculate that there is 0.01 moles of acetic acid and 0.005 moles of NOH. So dear, it's pure when we are going to add these both, what will happen? The 0.005 mole of NOH, that is a base, it will convert 0.005 moles of acetic acid into the salt. So the remaining will be how much? So we are going to see the remaining acid in formed salt. So the remaining acetic acid will be the initial concentration minus minus the number of moles which is being converted into the salt. So how many moles of acetic acid will convert into the salt? That is the 0.005 mole. It means 0.005 mole of NaOH is there. So 0.005 moles of NaOH is going to neutralize only 0.005 moles of acetic acid. So the salt form will be 0.005 molar and the remaining will be 0.005 molar. So see, now use the Henderson-Hazelwitch equation, that is the pH equal to pK plus log salt divided by S. It's a very common formula which we used to learn in our second semester or third semester. So for this, what you need to calculate the pK. And for pK, the given data was the K of acetic acid, that is 1.82 into 10 to the power minus 5. So when you calculate the pK, you will have an answer that the pK of this molecule will be 4.74. In the most of the time, the value of log will be given in your examination. So you don't need to worry about this. If this kind of question is appearing in your examination, so they will give you the value of log 1.82 into 10 to the power minus 5. So now put this pK value on the Henderson-Hazelwitch equation. So pH will be pK, that is the 4.7 plus log of salt upon acid. Here log salt concentration is 0.005, acid concentration is 0.005. So acid upon salt will be 1. And 1 means log 1 and log 1 means 0. So pH will be pK, that is 4.74 plus log salt by acid, and this value will be, so pH will be 4.74 plus 0, that is 4.741. So our final answer will be option C. So for these kinds of question, sometimes you need to do the calculation wisely. A simple mathematical error will end up at a negative or a wrong option. So what are the steps? You need to identify the reaction, then you need to calculate the moles, and then just find out the remaining concentration and form salt. After that, use the Henderson-Hazelwitch equation to conclude the pH of the molecule. Sometimes they give the pH and ask about the pK. So with the same concept, you will be able to find out the pK value also. Now, dear, moving to the next, and you can say the trending question. What I'm talking about, why I'm saying that this one is the trending question, because dear, in the most of the national institutes, like whether it's a NIPER, IIT, NICER, ICER, they all are working on the peptide type of molecule. So peptide type of molecule. So for the synthesis of peptide, we are in need of amino acid, and amino acid is having amines. So these kinds of questions can be appeared in the upcoming examination also. And the question is very normal. It's talking about the commonly used protecting group. See here, basically the two groups are there, protecting group and deprotecting. When we use the protecting group, when our compound, our molecule is having more than one functional group, but we want that reaction should go at only one functional group. Again, I am repeating, if our molecule, just imagine a molecule is R, C, that one, this one is OH, and this one is NH, right? NH. means the molecule is having the both amine and alcohol group. So in this case, if we want that the reaction should go only on amine position, so what we have to do, we have to mask this OH. So the masking, the protecting a particular functional group is known as protecting process. And the group which is being used for the protection is known as protecting group. So here you can see the basically the options, and these are the things that you need to remember. There is no shortcut of few things. This is one of them. So basically the protecting group is used to temporarily mask a reactive functional group to prevent unwanted reaction. And here is a list of few common protecting groups. And the question was related to the amines. So which one is commonly used in case of amines? So here you can see in case of amines, the commonly used is tertiary box. So T box will be the correct answer. So our correct option will be the option B. That is the T box. So correct option is option B, T box. So in these kinds of question, you need to remember that which functional group is protected by which protecting group. So here you can see a list of protecting group. For example, for the alcohol, we use the silyl ether or benzyl. For the aldehyde or ketone, we use the acetyl ketyl form. For the carboxylic group, we converted this generally into the ester. For the amines, we use the BOC, and for the thiol, we use the SSI. And the question was related to the amines, and for the amines, we use, that is the tertiary butyl oxycarbonate. And the common name is tertiary BOC. Now, here you can see the few very famous example of deprotecting group or deprotecting condition. Then what is the meaning of deprotecting? Deprotecting is nothing but to remove this particular protecting group. To remove this protecting group like acetyl, silyl ether, tertiary bulk, FMOC, to remove this, the condition or the molecule which we are going to use is known as deprotecting group or deprotecting condition. For example, the tertiary bulk can be eliminated with the tetrafluoroacetic acid or TFA, that is in acidic condition. So you need to remember, for example, SMOC can be deprotected by the piperity. So sometimes you need to remember few things like the guideline you have to remember, the name you have to remember, where you can use your tricks, your mnemonics. That is in case of reaction, in case of structure, you can use somehow your mnemonics or your tricks or the concept in the reactions only. You can't use your concept in these kinds of things in these kinds of direct question. Now, moving to the next question. And the question is related to the atomic absorption spectroscopy. Before moving to the next question, I would like to ask, is there any problem or any doubt to the question which we have discussed till now? Is there any doubt, dear Harika and any other student? Okay, glad to know that there is no doubt. So see, this question is related to atomic absorption spectroscopy, which is commonly known as AAS. AAS, that is atomic absorption spectroscopy. And there, this spectroscopy is a very advanced technique when we talk about the detections of the atom. So it's talking about what is the sequence of process during the atomization. So it's very simple. in this kind, we have already discussed atomic absorption spectroscopy in the analysis classes in very detail. So where you will be able to find all the concept about the atomic absorption spectroscopy. If you have not watched the video of that particular analysis lecture, you can re-watch that. So in case of atomic absorption spectroscopy, firstly, we nebulize the sample, then it will dissolve, then it will volatile, and then it will dissociate, and after that, it will ionize. So you need to remember, you can remember this with a simple trick, that is NDVDI. NDVDI. So this is the sequence which we use in atomic absorption spectroscopy. Just have a quick look of atomic absorption spectroscopy theory. So basically, there it's a analytical technique. Of course, it's a technique means analytical technique, which generally used to determine the concentration of a specific metal and sometimes few non-metal in a particular sample. It's basically measure the absorptions of light and give us a quantification value. So basically, atomic absorption spectroscopy used to determine the concentration of few specific metal or few non-metal, and it measure the absorptions of light. But there is one condition: before the measuring the light, the absorption, the compound must be in gaseous state. So remember, in the case of atomic absorption spectroscopy, your sample should be in gaseous state. Means it must be ionized. So your ionization will be the last thing. It will ionize, and after that, you will get your absorb light and you will get your quantification data. So simply remember this with a simple mnemonic NDVDI. So nebulizations, then dissolvations, then volatilizations, then dissociation, and the last one is ionization. So this was about the atomic absorption spectroscopy, which we have already discussed in very deep manner in the analysis classes. Now, the next question is related to the thermal conductivity. There, here is few gases, here is few given gases, and it's talking about that which of the following gases will have the highest thermal conductivity. So again, this question is like that you have to remember few numbers. So see, basically, the thermal conductivity is a phenomena which you need to remember, and the thermal conductivity of each of the gases of at 25 degrees Celsius is already well documented in a number of books and in number of pharmacopoeia. So you can easily find out the thermal conductivity, and you can remember that thermal conductivity of the given gases. So here the question is about the highest thermal conductivity, and the given options is nitrogen, oxygen, compressed air, or helium. So here you can see the thermal conductivity of each of the molecules. The helium is having a thermal conductivity of 0.151. The oxygen is 0.026. The compressed air is having 0.024. And the nitrogen is having 0.025. So with the help of this data, you will be able to identify that, okay, that the helium is having the conductivity, highest thermal conductivity. And basically this happens due to their low molecular weight and monoatomic in nature. Sometimes the question might be appears that why the helium is having high thermal conductivity. So remember, it's because of low molecular weight and monoatomic in nature. So it's similar to remembering of the molecular weight. Means if anyone is asking about which of these, like carbon, hydrogen, nitrogen, and oxygen, which of these four will have high molecular weight? So in this condition, what is necessary? The necessary thing is you must be able to know, or you must be able to calculate the molecular weight of these molecules, or you should know the molecular weight of these four atoms. So after that, you will be able to find out, okay, this molecule is having the high molecular weight. So this is this kinds of question get data based. So you have to remember few data. Now moving to the organic chemistry questions. This one is from the organic chemistry. In here, this is a representation that these kinds of question used to appear. So whenever the question is appearing in your examination, so there is a possibility that two kinds of question are two, not only two, they can ask in different way, but the two famous way. The first one is they will give you the complete reaction and they will ask the name of the reaction. And the second way is they will give you the product, right? Product, and they will ask you about the reactant. They will not provide you this reactant, and they will ask about the reactant. So this is the two very famous way of asking the question in GPAT or NIPER examination. So here you can see a carbonyl group is being converted into a alkane moiety. Means a carbonyl that is a ketone is being converted into a alkane. In hydrogen, see dear, NH2 NH2 is hydrogen. Hydrogen is being used. Okay, so hydrogen is being used and hydrogen is being used and the carbonyl is being converted into the alkene. So what will be the name of this reaction? So the name of this reaction is the very famous Wolff-Kishner reduction reaction. Here you can see a reduction is happening. Okay, so here you will be able to find the reduction is happening. So which reduction? See, the rearrangement is not here. So the Curtius rearrangement or Wolff rearrangement is not the correct answer. Okay. So you have two options, options B and option C, and you have to identify that which option is correct one. So simply remember with few tricks. The Clemenson uses zinc amalgam, ZnHg, along with acid which is frequently HCl. HCl. So you can remember Cl, Clemenson Cl with HCl. So if you are saying the zinc amalgam along with any acid or HCl, in the option means the reduction will be the Clemenson. And the given option is containing the hydrogen, which is not the zinc amalgam. Means the correct option will be option C. That is the Wolff-Kishner. Again, remember there, the Wolff-Kishner is a kind of reduction reaction in which a carbonyl group converted into the alkane in the presence of hydrogen. I am repeating, a carbonyl group will convert it directly into the alkane in the presence of hydrogen. Now, we are going to see the Wolff-Kishner. We are going to see the other reaction. See, in the case of Clemenson, what we have discussed, this is also a kind of reduction, but in this we use zinc amalgam. In the Wolff-Kishner, we use hydrogen. Now, few times the direct questions appears, and this one is the example of one of the direct questions. That is a Gabriel ring closure method is employed in synthesis of which molecule. The given option are option A is 1,4 oxygen, option B is aziridine, option C is oxygen, and option D is oxygen. So for this, you need to remember the Gabriel ring closure method. See dear, remember, Gabriel ring closure method is a kind of reaction as it's talking about the ring closure. which used for the synthesis of agility. There is no shortcut in this name is directly related to the agility. Simply remember this with a mnemonics like AG. So in Hindi, we use frequently AG in a very respective manner. So you can remember that AG give me few ring, right? Or you can say that AG bring me a ring. So A means agility, G for Gabriel's, and ring for a ring closure method. You can remember this method also. You can directly remember that Gabriel ring closure is directly associated with the agility. AG ring. Second, you can remember AG ring. A for agility and G ring means Gabriel ring method. So Gabriel ring closure method is used for the synthesis of agility. Moving to the few more very important questions, and the next question is related to the dipole moment. The dipole moment, we have discussed this in detail in the classes of general principle of organic chemistry or in the classes of general chemistry. So in the general chemistry classes, of course, it's since it's too long time, we are discussing this first time. We are discussing this first time after a very long time. So it's possible that you don't remember those concepts. So I'm going to repeat those also. The question is just talking about to identify the molecule which is not going to show any kind of dipole moment. So see, the given options are carbon dioxide, carbon monoxide, chloroform, and ammonia. So, firstly, read this option and try to give the answer by your own. Okay. So, Harika or anyone, you can give the option. You are having 20 seconds to give the option. Okay. See, we are going to see the detailed explanation that which of these molecules will not exhibit any kind of dipole moment. So, foremost, firstly, we are going to see what is the dipole moment. Firstly, let's see the correct option will be the carbon dioxide, and we are going to see the detailed explanation of this. Basically, dipole moment is a kind of it's a kinds of vector quantity and which having the both magnitude and directions. Okay, which having the both magnitude and direction, and it's measure the separation of positive and negative electric charges, and the unit of the dipole moment is dBi, and basically this is calculated with a formula, and that is mu equal to QR. Here, dear, mu is dipole moment, Q is the magnitude of the charge, and R is the distance between the two charge. Simply remember, if two molecule is there, A and B, and A is possessing partially delta positive charge, and B is containing delta negative charge. So in this condition, there will be dipole moment between these two, and this dipole moment will nothing but the multiplication of their charge and the distance between the A and B. And when we talk about the polarity, so see, a molecule will consider polar if it is having any kind of net dipole moment. Otherwise, it will be either the non-polar, if it is having the dipole moment zero, it will be non-polar. If any molecule is having few dipole moment, it will be polar. So, with the help of dipole moment, you can remember the concept of polar and non-polar also. Any molecule which is possessing any kind of dipole moment will consider polar. And if the molecule is not having the dipole moment or it's a zero, then it will be non-polar. So the given option was of see here the four given option was carbon dioxide, carbon monoxide, chloroform, and ammonia. So we are going to see the why the carbon dioxide was the correct option. When we talk about the carbon monoxide, see here, it's our CO. It will have a dipole because it is having a difference in electronegativity. As I have discussed, the charge is basically the difference in their magnitude. So if there is few difference in their electronegativity, means in case of the carbon and oxygen, that is the carbon monoxide, there is a electronegativity difference between the carbon and oxygen. Means this molecule will have few dipole moments along with this molecule is linear and their bond will be polar. So remember this also. So carbon monoxide will have few dipole moments. The reason behind this is there is difference in electronegativity between the carbon and oxygen. There, these all we have already discussed in detail in the classes of general chemistry. Now talking about the carbon dioxide, it will not have any dipole moment. The reason behind firstly, it's a linear molecule, and when we talk about the C double bond O, then it it becomes net zero dipole moment molecule because due to their symmetry, they cancel out their dipole. Due to their symmetry, they cancel out their dipole. And it's a linear molecule, and due to the said symmetry, the carbon will cancel out the dipoles of the oxygen, and this oxygen will cancel out the dipoles of the carbon. In the very simple language, you can remember it will have the net zero dipole moment. And when we talk about the ammonia, you will be able to identify there is a huge difference between the electronegativity of nitrogen and hydrogen. So this will also be this molecule will also have few dipole moment. While in case of chloroform, there is also some dipole moment. So the correct option of this given question will be the carbon dioxide. Now, moving to the next one. Here, this is the question from the first step. And this is a kind of question which are very confusing. At the same time, it's a question of the fraction of second. In the 2019, the examiner have asked the PM indicator are used in which kind of titration? See here. The PM indicator is nothing but the metal ion indicator. Okay. So it's a metal ion indicator. So when we talk about the metal ion indicator, so just remember, metal ion indicator is used in complexometric titration. Just simple. What is this complexometric titration? You might be aware that the complexometric titration is a kind of titration in which we are going to detect the metal by titrating it with the help of any ligand. And when the metal and ligand reacted, they make a complex. So that's why it's known as complexometric titration. And the indicator used in complexometric titration is known as metal ion indicator or PM indicator. For example, you can remember this one. That is the iriochrome black, commonly known as ED. One of the example of PM indicator is iriochrome black tea. You can simply remember with a trick of like the irio is a person who is running the chrome by taking the black tea. Irio is running the chrome by taking the black tea. So the name of the indicator is idiochrome black tea. Okay. Yes, it's correct answer. Malachite green is also a correct one. There are a lot actually. So EBTN there are a lot. So these kinds of indicator we use in complexometric titration for the detection of metal ion. So remember, the question might be appear like this also. PM indicator used for what purpose? So remember, the PM indicator will used for the purpose for the identification of metal ion. In the case of redox titration, we use either the self indicator or other kinds of indicator. Acid-base titration, we use like phenolphthalein, methyl lead, methyl orange, or other. In the case of non-aqueous titration, we use the crystal violet, alpha-naphthalobenzene, and so on. And in case of complexometric, we use metal ion indicator. So the correct answer will be the option D, complexometric titration. And the next question is very interesting question. So, dear, by the God grace, I was able to sit in the GPAT 2019 examination. So this was the question where I got confused and I clicked on the wrong option. So the question was related to the amylopectin, and the given option was yes, yes, Harika, I did the same mistake. The C1 is the not the right answer. So this is what I'm going to discuss. So see, so the amylopectin in the given question was having the component of the starch. So in the most of the time, what happens, students see the starch and iodine and just they click on the option C, that is the blue. But this one is the wrong answer. So I did the same mistake and I end up with a negative mark instead of getting 4 positive. So the correct answer of this is red, purple, or reddish brown. See here, I'm going to discuss the explanation of this also. So basically, if we talk about the starch, so there starch is having the two major components. Starch is having the two major components. The first one is amylose and the second one is amylopectin. So when we talk about the amylose, it's a linear starch component and it forms deep blue complex with the iodine. See, starch is composed of two major components, amylose and amylopectin. So amylose will give the deep blue color, while amylopectin give a reddish brown or reddish purple color with iodine. So remember, this was the question where I got the wrong, where I also chose the wrong options. So these kinds of question used to appear in the examination to confuse you, to confuse the attempters, to confuse the student. So be very aware and be very careful before solving these kinds of question. You need to read the question very carefully. So the correct answer of this question is red purple. Means amylopectin when it will react with the iodine, it will give a reddish purple color. Now the one more question which is related to the structure of beta blocker. Structure of beta blocker. In the beginning of the classes, we have discussed about the different kind of structure of beta blocker molecule. So it's also related to the beta blocker. So the question is asking about which of the following is containing 135 thiazole ring in the structure. Dear, this question was appeared in the 2019 examination, but all the given option was the wrong one. Yes, this happened in 2019, and it happens a lots of time in the GPT examinations. So in these kinds of cases, what is necessary, you should attempt the question. If any student is attempting the question, they will get the full marks on these kinds of questions. So the question was related to the beta 1 selective blocker to identify which of these is having 135 thiazide in their structure. But all the given options are incorrect. See, we are going to see the structure of all these sotalol, timolol, penbutanol, and pindolol. None of them is containing 135 thiazole ring. Also, are correct. The given option as per the given option as per the GPAT, as per the AICTE or as per the GPAT conducting board was the timolol that year, but the answer was the question was eliminated after that, and all the attempted received the 5 marks for this particular question. Here in the 2019, a lots of question was this kinds of like if I remember uh, precisely, so it was either 4 or 5. So in the case of 4 or 5 question, the given option was not the correct. Now see the structure of sotalol, timolol, pindolol. This one is penbutanol. So these all four structure. Neither of these four is containing the 135 thiazide. Okay, so these kinds of question used to appears. It's basically it will be 1, 2, 3, right? It will be 1, 2, 3 or 1, 2, 3, right? 1, 2, 3 or 1, 2, 3. So this will be like now we are going to see the other question. And now the question is related to a reaction, a very famous reaction. We are going to see this reaction in detail also. So the question is related to the two functional groups. The first one is alpha haloester and the second one is aldehyde or ketone. And the question is asking that what will be the product if the alpha halo the question is talking about the name. Okay, so I would like to correct. The question is talking about the name of the reaction. As I have discussed earlier in the question, either they will talk about the name or they will talk about the reagent. Here also the question is asking for the name of the reaction. And the question is, if the alpha haloester in aldehyde is reacting in the presence of a base that is sodamide, then it is giving alpha beta epoxy carboxylic ester. Then what will be the reaction? What will be the reaction? So dear, for this, you need to remember the different kinds of reaction. So for now, just remember the correct answer is Dargen glycosidic synthesis. So dear, Dargen glycosidic synthesis is a kind of synthesis which we are going to discuss here. So in this synthesis, what used to happen? A carbonyl compound, that is either the aldehyde or ketone, reacted with alpha haloester. See here, this one is ester, and this is the alpha position. So this will be the known as alpha haloester. In the presence of base, either in the sodamide or in the sodium acetate or in the sodium ethylase, sodium ethanoate. So in the presence of base, this reaction happens. And when this aldehyde reacted with the alpha haloester, it gives alpha beta epoxy carboxylic ester. So the product is alpha beta carboxylic epoxy ester. See, this one is alpha beta epoxy and this one is ester. So remember, Darjan glycosidic synthesis is the kind of synthesis in which the alpha haloester react with the aldehyde or ketone to give the alpha beta epoxy carboxylic ester as a product. Okay. Now we are going to see the next question, and it's related to the one of the most famous antibiotics. So here the question is related to the identification of the product. And the given things is the primary product. Okay. Yes. The option B is the correct one. Good. Great. So the question is related to identify that what will be the product synthesized when 6-APA is being reacted with the para-hydroxy phenyl glycol. See here, the 6-APA is 6-amino-penicillinic acid. And para-hydroxy means the molecule is having para-hydroxy phenyl glycine means phenyl is having hydroxy group at para position. So then if you remember the structure of these all carefully, so you can easily eliminate the ampicillin and carboxylicin. Now the remaining one is vacampicillin and amoxicillin. So now we are going to see the structure of amoxicillin and their sequence. So see, the correct option will be the option B. And well done, Harika, and the option B is the correct one. Now we are going to see the how this amoxicillin used to synthesize in the lab cereal. So when this 6-APA, that is the 6-amino-penicillinic acid, reacted with the para-hydroxyphenyl glycyl ester, then it gives the amoxicillin. And this one is the structure of amoxicillin. Here, this one is the beta-lactam ring, dear, right? This one is the beta-lactam ring, and this one is the penicillin ring. Penicillin ring. And the overall structure is the structure of amoxicillin. So remember how this amoxicillin synthesized, then 6-amino penicillinic acid reacted with para-hydroxyphenyl glycyl methyl ester. So the correct answer will be option B. Now, moving to the one of the reaction which is more related to our 11th, 12th question. It's more related to our 11th, 12th question rather than our B5 question. The question is very simple that the conversion of aryl diammonium chloride to aryl chloride can be achieved in the presence of what? So the question is talking molecule that is in diaryl ammonium cases, diammonium cases like N2Cl type cases, right? N2Cl type. So this one is aryl diammonium chloride N2Cl. This one is aryl, this one is diammonium chloride. So the question is asking if you want to convert this into direct aryl chloride, that one is this one means the chlorobenzene. So which you are going to use? Cereal. So this question is related to the Sand-Meyer reaction. In the Sand-Meyer reaction, we can convert the aryl diammonium salt into the aryl halogen. And for this, we use the copper 1 chloride. So always remember, copper 1 chloride uses in Sand-Meyer reaction. Sand-Meyer. Remember the name. This is Sand-Meyer reaction. And the question is related to the Sand-Meyer reaction. Now we are going to see the overall reaction. So the reaction generally begins with the amines. And when this reacted with the molecules in different steps, in the intermediate, it gives diammonium salt. This is the N2Cl salt, right? Aryl diammonium. And when this reacted with CuCl, CuCl means here the valency of the copper is 1. So this one is CuCl. So the correct answer will be copper 1 chloride. So the option B is the correct one. And the question is related to the Sand-Meyer reaction. Now, moving to the next one, just okay. So the next question is related to the traveler diarrhea. Dear C, this is a kind of problem and this is a kind of question which it basically belongs to the pharmacology part, but it appears in the chemistry portions in GPAT 2019. So the question was asking about the right combination for the severe cases of traveler diarrhea. It's a very it's a very funny disease, you can say, but it can convert it into a very severe case. Basically, the traveler diarrhea is nothing but a case of diarrhea where a person suffering from the diarrhea due to the traveling means, see, imagine a condition, you are going to travel the African country, right? And you becomes a patient of diarrhea. So this happens, and this kinds of diarrhea is known as traveler diarrhea. So dear, for the traveler diarrhea, we need to remember few basic concepts. That the traveler diarrhea usually completed or usually heals by the normal medication. And it's mostly caused by the E. coli or the different kinds of bacteria like Salmonella or Shigella or any kinds of bacteria. And sometimes it can be due to the viruses or protozoals. So this is a kind of diarrhea which happen, which affected a traveler. That is why this diarrhea is known as traveler diarrhea. It's affect the traveler in the visiting region, and this happens due to either the poor sanitization or the contaminated food and water. And the symptoms of these are the abdominal pain, nausea, fever, dehydration. In the most of the cases, this diarrhea can be treated by the taking the normal medications or by the taking the correct balance of the electrolyte. But if the case becomes severe, then we used to give a combination of trimethoprim and sulfamethoxazole. So the option D is the correct option. So, therefore, today this is our last uh, slide. And the remaining we will discuss in the next session that is going to happen on the 4th of April. So till now, any doubt, dear anyone? If is there any doubt, I will re-repeat that. And Harika, it was glad to see you actively participating in the question session. It's good habit. Yes, any doubt? Any one of you? You can type. Yeah. You can type if you are having any doubt. Okay, so I'm going to end this session, and the remaining questions of the 2019 chemistry portion will be discussed in the upcoming session. What you need to do, you should read those questions and answer properly, and then you should attend this session. Then you are definitely going to definitely going to enjoy the session, and the remaining question will be discussed on the 4th of April. Thank you for attending the session. Thank you so much.